Hello everyone. Today we're going to go through a quick overview of Kinect Evolution, and in particular the actual source code to the sample you may have already seen on Windows Store. My name is Carmen Soriano. I'm the developer support engineer for KinectforWindows, and you may have seen me at some of our public events or throughout the year at our hackathons. I'm also on our forums, and I've also guest posted on our blog. We're providing Kinect Evolution as a full sample and with source code to the KinectforWindows Sdk Browser tool. If you've not already done so, you may want to download the SDK, and this tool will come as part of that install. The tool will be dynamically updated through the internet, so if you're looking for the sample and you don't have access to the internet, this will come dynamically whenever you're connected. We're releasing the code to help developers build more Kinect applications, and in particular Windows Store apps. The sample was designed to give you reusable components that you can use within your own apps, but if you are more comfortable, you can actually dig into the code a little bit further and help develop some of your own more ideas that you can use in your own code. To get the most out of this video and the SDK and the sample code that you find, you may want to have a good knowledge of DirectX and C++. The components were developed using that as a base to help build out more performance and capability. That said, we will demonstrate how you can use these components within your own Windows Store.NET application. Knowing DirectX and C++, this is just going to give you an advantage to digging deeper into that code and building out more advanced topics and concepts. With that said, let's go ahead and look at Kinect Evolution from the Windows Store, how you get it, and we'll go from there. Okay, so if you haven't seen Kinect Evolution before, we're just going to show you quickly how to get that from the Windows Store. So if you've never used the browser here, so this is our Windows Store, and we actually have a Kinect Evolution or the KinectforWindows collection, and that's the easiest way to kind of find things. Is if you come to collections and come over here for the KinectforWindows collection here, you'll see Kinect Evolution is right here. We just click that, click install. When you first run Kinect Evolution on Windows machines, because there are the privacy settings of Windows, you have to allow for the microphone and sensor to work. So here you can see on the left side, you see the depth mask view, infrared, color, IR and color, and you can watch the other video that we have posted that goes more in depth into this application, so that way you can see how you can demo this to your friends or family or business associates. To begin, I'm going to show you a quick way to get to the source code and how to launch the Sdk browser. So from your main Windows desktop here, we can click on the search, and we're going to look for Sdk Browser. So this is our KinectforWindows Sdk Browser. When this launches, you'll see the view here is of all the samples and all the tools that come with our SDK. You're going to go through the list and find where we have Kinect Evolution, and you're going to come down and click on the install button. And once you have that, this is going to ask you where you want to copy the source to and go through the process of copying the sample to your hard drive. We're going to select a folder here and just click OK. Once this downloads and copies to your hard drive, it will then give you the option of opening that folder and creating and launching the solution file. When this launches, you'll note that Kinect Evolution is launching in Visual Studio 2013. This is actually a requirement because we are using a component of the Windows 8.1 SDK called the Swap Chain Panel. This is only available in Windows 8.1. So if you are writing a Windows 8 application, then feel free to use VS 2012, but understand that the code that you're going to see here probably won't work, or you'll have to repurpose it for that environment. So As I said, when you launch the project, this is going to launch Kinect Evolution. There are actually two separate projects here. One is a controls, which is actually written in C++, and a UI layer that we call Kinect Evolution XAML. This handles mostly the layout and control of how the application works and what you're seeing really in the store application when you run it. We're not going to get too much into this because we're going to recreate a simple new Kinect Evolution sample for you in a minute. The main part of this is going to be the Kinect XAML controls that are written in C++. So let's open this up. And when you see the project here, there's a lot of boilerplate code that handles things like the Blockman mesh rendering, the audio panel rendering, the depth mesh, all the panels that you saw in the Kinect Evolution. There's going to be a one-to-one relationship to what you see here. So when you see a panel, this is where the code that you'll see for rendering or handling the DirectX rendering stack, we have a DirectX panel. From there we derive something called a panel ourselves, and this really is the base panel that all those other panels are being built on top of. So if we look at a simple infrared panel, we just open this up, we'll see here that everything is inherited from that panel, and what we're doing is just simply creating some boilerplate, passing an infrared stream source from our Kinects, and then it'll handle rendering and updating and pulling frames from the SDK, which is done in the CPP file here. So, the first thing we have to do as part of the infrared panel is create the device resources. So we are creating something called a ramp effect. This actually allows for rendering of the different texture that you see when you render the grayscale image of the infrared. We're creating an IR texture, so where we're copying the IR data from the Kinect so that way we can use it later. We're also creating this grayscale texture that we use in a shader later on. And once you get your hands on this code, you'll see a little bit more of this, and you can take apart the code and see how it works. What we really want to do, though, is kind of show another example of the panel is the Blockman panel. From the Blockman panel, we'll see that this is a little bit more complex in that we're using the body data that we get from the Kinect SDK and building on top of that a skeletal system where we're drawing blocks that represent the arm, the legs, the torso of the body, and based on that hierarchical information we're able to rotate the joints and simulate how you see how the arm is rotating. If we look at this real quick, things seem a little complex. We're defining what we call a structure in C++ of scale, center from parent, skeletal joint information, so that we get from the Kinect and its parent index, because you need to know from one joint to the next whose parent it belongs to. So here we're just defining the base skeletal structure of the blockmen themselves. Down here we're actually creating what we call the blockman structure, so all the orientations and positions for those body joints, as well as the transformations that are required to move the blocks into their positions. And then really the panel itself. So how does this render on the screen? So that's what these panels represent, is really the rendering that's required to see them on screen or in your UI, somewhere in your UI. As we see here, as we did with the infrared sample, the Blockman panel really has a public property called body source. That's the only data we're getting from the Kinect, and from that it handles update, render, drawing, render loops, when bodies are ready, how to take that data and integrate it into the system. And again, all the source code is here. You can go through and see how each one of these components plays a factor in how these components are built up. What I want to do now is actually go into how you might use this in your own application and do a quick sample of, hey, how can I make this work for me? So here we're going to go into Visual Studio again. Again, I'm using 2013. You can use Express editions of Visual Studios. And again, we're using 2013 because of the DirectX swap chain panel control that we're using as part of Windows 8.1 SDK. So we're going to just create a new project. Here it's going to be a Windows Store application. We're not going to do a universal app. We're just going to do a blank C++ project. We're going to call this New Evolution. And we're going to create this in our C code folder. And this is a .NET C# XAML application for Windows Store. If you're not familiar with XAML, it's just a series of markup that you'll create your UI layer and some source code behind the scenes to do some complex stuff. So now that we've created the project, we have our solution on the right here and our code on the left. We're going to go through and add Kinect, the capability to use Kinect to this application, and then we're also going to add the ability to use those controls. So the first thing we're going to do is add the Kinect. So under References, we're going to add a reference here, and under Windows 8.1, under Extensions, you'll come down to Windows Preview.Kinect. Right now you'll see that there's a caution symbol or a warning letting us know that there's something not right. This is because right now the target project is actually any CPU. Kinect requires either x86 or x64 builds, and because this is targeting any CPU, it doesn't understand what it needs to do. So we're going to come in here and actually fix the build environment to make sure that we're not actually building for the wrong type of processor. So we're going to remove this any and ARM because we don't support ARM for KinectforWindows. The other thing we need to do, so that was the solution build settings, but we also need to come down to the project and remove any and ARM. So now you'll see that resolved the KinectforWindows warnings that we saw here. Okay. So once we've done that, we're going to go ahead now and add Kinect to our application. So this is the app.xaml. We don't need that, so let's close that. And we're going to come to our main page. And there's a couple things we want to do here. We're going to come in here and change the name of our main layout. So that way we have some way to reference that in code. So we're going to give this a name called main layout. And we'll get to this in a minute. So if you've never used XAML before, you can come in here and add different controls like text box, and some buttons. But we're not going to use any of that right now. We just want to do a simple application. So we're going to come into the code behind, and we're going to add an instance of the Kinect to this application. The way we do that is we're going to add our using statement for the Windows Preview.Kinect namespace. That'll get us access to the APIs we need. From our main class here, we're going to create an instance of the Kinect sensor. And we're going to come in here and actually set that. This.sensor.open. So this is the minimum amount of code that you need to actually create a sensor and start using Kinect. We need the open so the runtime actually understands how to communicate with your application to notify it when any frames are ready, so that anytime you call one of the APIs, it knows that you're authorized to use it. One thing you'll note from this application right now is if we were to go ahead and run it, when we launched Kinect Evolution, it gave us a dialog that said, hey, we need to use your webcam and microphone. The way we do that is we have to enable capabilities on this application to make that request. And the way we do that is through our package app manifest. And we're going to come down here to capabilities, and we're going to turn on microphone and webcam. That will enable the sensor to actually the application to bring up that dialog and make that request to ensure that we have the ability to communicate with the sensor. So right now there's not much going on, and I don't really want to stop here because we have these cool controls that we just talked about in Kinect Evolution. So the way we're going to do this is we're going to add that project into this application so you can use those, reuse the controls and make your own new Kinect Evolution application. So we're going to come down here and we're going to add a new existing project, and you'll note here that we're in the Kinect Evolution XAML project. On your screen you may be starting from this folder here. So what you need to do is find out where you copied your code to. We're going to come into the Kinect XAML, and actually we want to be in the XAML controls project and select the project file. This will import that entire solution, the entire project from Kinect Evolution into your particular application. So you have direct access to all the code that was in that other project right inside your code. So if you want to make changes on the fly, which we'll do here in a second, you can do that. So now that we have this project, we need to make a reference to it, because right now our application doesn't know about those extra controls. And you come to the solution and add a reference. So now that we have a reference to the controls, we're going to go ahead and wire up one of those controls. So we're going to add Kinect Evolution. You'll note right now that we're not seeing the namespace resolve. This is because we haven't actually built the project, so the DLL is not, it doesn't know how to get the IntelliSense from that project. So let's go ahead and build this. And now if we try to add that namespace, you'll see it now resolves. And the control we're going to play with today is actually Blockman. A lot of people like this demo because it really shows dynamically the power of what's coming off the Kinect data and the Kinect runtime. So we're going to create an instance of Blockman panel. We're just going to call this panel. And right now, so in between our open and starting the Kinect, this is where we're going to create the panel itself. The panel, to use Kinect, it needs something from the Kinect. It doesn't need the Kinect itself. What it really needs is the body source, or the body frame source from Kinect. So we have a property called body source, and we're going to say this.sensor dot body frame source. We're just going to pass that. And you remember here we called open on the sensor. The one thing you have to do for the panels is tell them to start. There is one missing piece though. Right now we've built this panel in code. A lot of the XAML developers will actually do this on the UI directly, which you can do as well, but I've chose to do this in code behind to show you all the code that the minimal amount of code that you need to actually create one of these. We need to tell the UI how to, that this control wants to be part of the visual tree. The way we do that is, remember I called that main layout. So we're going to come back here and say this.mainLayout.children. So children is the property of controls that are part of the rendering tree, visual tree. So we're going to say add the panel. And that is it. So we're going to go ahead and run this. We're targeting x64. Now the choice to choose x64 versus x86 really depends on what you're doing in your app. Again, we see this dialog that says, can new evolution use the camera? We want to allow. And right now, my sensor's turned on, but you don't see anything. Kinect requires that you're half a meter away, and I just moved into that range, and now we have Blockman. And if we had more people, we could show a lot more information. My legs are cut off by the table, so I'm doing a yoga pose. But this shows you that you can get the controls into your application. So right now, he looks pretty good, but some people are different shapes and sizes. Maybe you don't like squares, maybe you want some different shapes. So what I want to show right now is how you might go about changing what this looks like. And so maybe this might be your first introduction to how C++ and DirectX work, but we're just going to do a quick modification on how this is drawing and go into that a little bit further. So now from here, let's find where that blockman panel is being created. And from here you'll see there's a blockmanpanel.h and CPP file. If you're new to C++, .h files trying to give you the structure of how the code is laid out, where the CPP is actually the implementation. If you're new to this, it's basically taking what you see in .NET and dividing it into two pieces, because a lot of this you want to reuse. You might want to give a compiled DLL to your friends, but you don't want to let them see how you actually wrote the code. In our case, we want you to see the code, so we gave you everything. So blockman panel, this is the like I said, we talked about this a bit, and this is the general structure of how blockman is generated. We have, the blocks of code, how are the pieces fit together. And when we look at these properties, you'll see that they're blocked off in these curly braces of 1, 2, 3, 4 properties. And we talked about this before, but we have this XM vector, which is the scale. How big is it? Center from parent. What's the offset from the parent? And the joint itself. And really, who's its parent? So, because these are just joints in space. Joints don't have any concept of connection, so we're generating that as part of the code. So what we want to do here is we want to modify a bit how the body looks. So we're going to try to make this more realistic to my body shape. I'm not really muscular, so the main thing we want to do is that would be the mid-range of my body. We want to make this a little bit bigger. So we're just modifying X and Y just with a simple change, and I build this. We're going to see that the rendering code, again, I'm going to step back just slightly, and now you'll see I have a big pot belly. Something simple, something creative, but simply building that out, you now see that, hey, the shape is looking a little different. If you're a seasoned KinectforWindows developer or a computer vision specialist, you may want to actually physically check out how the person is built and change the sizes dynamically, so that way you can actually manipulate how the bodies look that look closer to what the users are. For me, I know it's just me in front of the camera. I can do these quick manipulations. Maybe I want Superman instead. So we can come in here, we can undo what I did before, and I want to make him slightly more buff. So if we restart or rerun the code, it's going to ask me to save. And now you see I'm more slender. I just lost about 20 pounds. The other thing you might want to do is, maybe you don't like squares or cubes. Maybe you want to do Sphere Man or some other type of rendering effect. We don't have a lot of time today, so we're not going to show you how to do that, but I want to show you where you can find that code. So blockman is comprised of 3 different pieces. One is the mesh, one is the effect, how does it render, how does it color, and the other is the panel, which takes all those pieces and puts them together. The other piece are the shaders that make up, how do I render things in the world? And again, these are more advanced topics for DirectX, HLSL language, textures. They're a little bit more advanced for this quick introduction. But again, I want to let you be aware of where this code lives. So if I wanted to change what the body looks like, instead of using squares, I can come into the blockman mesh. So this is responsible for drawing the blocks that make up those bodies. You'll see I have an initialize, I have a render, and really I have this vertex information of where those blocks live in space. So what I want to do here, if you know how to render spheres, you can come in here and manipulate the vertex information. So in 3D you have a concept of XYZ where vertices live in space, and then you have a concept of indices of how those vertices join together. And again, this is where we're building out the vertex information. So again, we're building out blockmen vertices. You're going to have to change that structure. So right now they're just big blocks of squares, and we're just saying, you know, this is how you build a box. If you look at any of the DirectX code, you'll see this code reused in many places. Again, we're just repurposing or reusing the concept of drawing cubes to draw the body. And really what it is, it's actually drawing one box per joint. The other thing is, maybe you don't like the shaded cubes that you see on the body. You can come in here and actually add some different effect. So right now we're taking world, joint, and light direction to kind of light that body. If you want to change how the shaders work, you come into the effect of that blockman and actually come in here and manipulate. You know, maybe I'm going to do a different shader, so you're going to have to come in here and change what actual shader is being loaded instead of this pixel shader, or what texture is being loaded instead. And again, the code's all here. This is exactly what we use to actually publish the KinectforWindows Kinect Evolution application to the store. And if you have any questions, please come by and see me at any of our events or see me on the forum. Thanks.